In this video, I am going to explain the turn-on methods of SCR. We know that the SCR has two stable states. So that is a forward blocking state and forward conduction state. Okay, switching the SCR from its forward blocking state to forward conduction state is nothing but turning on the SCR. We can call it as in another words called as triggering the SCR. So triggering is nothing but switching on the SCR from its forward blocking state to forward conduction state. Okay, so this is nothing but triggering of SCR. Generally, the criteria for triggering the SCR depends on the several variables like supply voltage, okay, the supply voltage across anode and cathode terminals, and gate current, and the temperature of the device. Okay, so these are the different variables. Okay, so because of which we can trigger the SCR in various ways. Okay, so there are various methods for triggering the SCR. Okay, so to make it on state or to force it to on state. Okay, let us take a simple structure of an SCR. Okay, so that is a SCR with the anode and cathode and gate terminal. Okay, so this is the anode of the SCR, this is cathode of the SCR, this is the gate terminal of the SCR. Suppose the voltage applied across the SCR, okay, the voltage applied across the SCR is like this. That means, the anode is made positive with respect to cathode, then the SCR is under forward bias condition. That means the SCR will be forward biased when the anode is made positive with respect to cathode. Okay, so whenever it is under forward bias, so okay, the SCR can be made to conduct or switch into the conduction mode or conduction state, okay, by using different methods. Number one, forward voltage triggering. So number two, temperature triggering. Number three, dV by dt triggering. Number four, light triggering. Number 5, gate triggering. So there are 5 types of methods to turn on the SCR or to trigger the SCR. Number 1, forward voltage triggering. Okay, number 1, forward voltage triggering. Number 2, temperature triggering. Number 3, dV by dt triggering. Number 4, light triggering. Number 5, gate triggering. Okay, so now let us see all these methods one by one. Okay, number 1, forward voltage triggering. Okay, forward voltage triggering. So one of the commonly used SCR turning on methods is simply by increasing the forward voltage or the voltage during the forward bias condition of an SCR, okay, to trigger the device. If we increase the forward biased voltage across anode and cathode, then what happens, we know that during forward blocking state, SCR has two forward bias junctions and one reverse bias junction. Okay, let us see the internal structure of an SCR. This is the electrode anode and this is an electrode cathode. Okay, there are 3 junctions. So let us assume this one as junction 1, this is junction 2 and this is junction 3. Okay, so this is the P layer, N layer, P layer and N layer. Okay, there is a gate terminal connected to the inner P layer. Okay, so this is the internal structure of an SCR. Whenever the forward voltage or the anode is made positive with respect to cathode, then this SCR will be forward biased. So when SCR is forward biased, the junctions J1 and J3 are forward biased. Okay, and junction J1 and J3 are forward biased, but junction J2 is reverse biased. Okay, so that is why, because of the reverse bias at junction J2, there will be a depletion layer formed here. There is a depletion layer. So this depletion layer does not allow the flow of current from anode to cathode. So this is called as forward blocking state. That means during forward bias condition of an SCR, if there is no current flowing from anode to cathode, then that means the flow of electron is blocked. So that state is called as forward blocking state. Okay, so during forward blocking state, okay, if I keep on increase the forward voltage across anode and cathode, okay, so at one instant it is seen that the depletion layer gets vanished. Okay, so the increase in forward voltage across anode and cathode vanishes the depletion layer at junction J2. As soon as the depletion layer junction J2 is vanished, this J2 junction will become forward biased. Okay, so forward biased. So here then whenever this junction J2 is forward biased, there is high amount of current started to flow from anode to cathode. Okay, that means the device is now conducted. Right, that means device is conducted, or device has been brought from its forward blocking state to forward conduction state, called as triggered. Okay, so by increasing the forward voltage across anode and cathode terminals. Okay, this is because right, the minority charge carriers accelerating voltage at junction J2. This further leads to an avalanche breakdown of the junction J2. That means the instant at which the depletion layer is vanished is called as avalanche breakdown. Okay, so the voltage, okay, or the forward voltage at which the junction J2 depletion layer is vanished is called as avalanche breakdown voltage. So we can call it as a forward breakover voltage. We can call it as a forward breakover voltage FBO. This is the voltage, forward breakover voltage. Okay, so this is called as forward voltage triggering. Right, so forward voltage triggering means if we keep on increasing the forward voltage applied across anode and cathode, junction J2 will be forward biased, then the device will be conducted or triggered. Whenever device is turned on or triggered, the voltage across okay, SCR, which is called as VT, okay, V suffix T, is 0. Ideally it is 0, but practically the voltage across SCR whenever it is conducted is, okay, 1.5 volt to 2 volt. This is the voltage drop across the SCR whenever it is turned on. Okay, so in practice this method is not employed because it needs a very large anode to cathode voltage, or large voltage across anode and cathode. And also once if this high forward voltage applied across anode and cathode is greater than that of the specified forward breakover voltage rating of an SCR, then there will be very high currents flown from anode to cathode, which may damage the SCR. Okay, so that is why practically this type of triggering is avoided. Number 2, temperature triggering. Okay, so during forward blocking state of an SCR, there are reverse leakage currents flowing through the junction J2. The amount of flow of leakage current is depending upon the temperature of the device. If the temperature is increased to a certain value, the number of hole pairs, the number of hole pairs also increases. So here the majority carriers in this region or in this layer is electron, the majority carriers in this layer are holes. Okay, when temperature is increased, the number of hole pairs also increases. So this causes to increase the leakage current further, and it increases the current gains of the SCR. So this starts the regenerative action inside the device. So that is why whenever the temperature at junction J2 is increased, breakdown occurs. At particular instant where the breakdown occurs, the device will be conducted. So that is why this type of triggering is also called as false triggering. So this type of triggering is practically not employed because it causes the thermal runaway, and hence the device is or SCR may be damaged. Okay, so this is all about temperature triggering. Number 3, dV by dt triggering. Now, during forward blocking state of an SCR, J1 is forward biased, J2 is reverse biased, J3 is forward biased. Okay, so that means, here it is simply looking like a capacitor. These J1 and J3 are acting like conducting plates in capacitor, that is positive plate and negative plate. And this space, this space is a dielectric medium which is considered to be like a depletion layer. Okay, so here a depletion layer is considered as a dielectric medium. Okay, dielectric medium because of space charges in depletion region. What is the current flowing through the capacitor? Current flowing through the capacitor is equal to C dV by dt. Right? Here the junction J2 has some certain capacitance. If the dV by dt is increased, what happens? The current flowing through the capacitor also increases. So that means if the rate of change of voltage across anode and cathode terminals is increased, okay, then the charging current, okay, will also increase. So that means increases the charging currents of the capacitance at junction J2. So the charging current of the capacitor, whenever it gets increased, at particular instant, it is seen that here there will be high amount of current flows from anode to cathode. So the increased charging current causes the device to get triggered or to get turned on. So this type of triggering is known as dV by dt triggering. So when the current flowing through the device is increases at one particular instant, device will be conducted. Okay, so that means with the help of dV by dt, okay, device is conducted. So the rate of change of voltage across the device, okay, conducts the device or triggers the device. So such type of triggering is called as dV by dt triggering. Okay, dV by dt triggering. However, this method is also practically avoided because it is also called as false triggering. Okay, this is also called as unwanted triggering, and also it provides or it produces very high voltage spikes across the SCR. So it may damage the high voltage spikes across the SCR may damage the device. So that is practically this type of triggering is avoided. Next, number 4, light triggering. An SCR is turned on by light radiations, is also called as a light activated SCR. Okay, the SCR turned on by light radiations is also called as light activated SCR, LA-SCR. This type of triggering is employed for phase controlled converters in HVDC transmission systems. In this method, light rays with appropriate wavelength and intensity are allowed to strike the junction J2 where the depletion layer is formed. When the light struck on the junction J2, there are electron hole pairs increased in the inner P layer. So we can show here a Thyristor, which is also called as light activated SCR. Okay, simply represented symbolically like this. It has anode and cathode. So in a circle with gate terminal. So there are the radiations of the light, okay, struck on the junction J2 where the depletion layer is formed. Okay, this is anode and this is cathode and this is gate. So these are the light radiations. When the light radiations, okay, with certain or appropriate wavelength and intensity, okay, are struck on the junction J2, then the electron hole pair gets generated in the inner P layer. So when electron hole pair gets generated in the inner P layer, this junction J2, which is reverse biased, okay, will become forward biased, and hence the device will be turned on. Right? So this type of triggering is called as light triggering. Number 5, gate triggering. Actually, gate triggering is the most common and efficient method to turn on the SCR or to trigger the SCR. So when the SCR is of under forward bias condition, that means whenever SCR is in forward blocking state, okay, if we apply a sufficient voltage across gate and cathode terminals, it may inject the electrons into the junction J2. So when electrons are injected to the junction J2, then the reverse leakage currents through the junction J2 will be increased, and hence the breakdown of junction J2 occurs even at the lower values of, or even at the voltage lower than the forward breakover voltage. Then device will be triggered. That means device gets turned on. It happens at the voltage across the anode and cathode lower than the forward breakover voltage, called as VFBO. Depends on the size of the SCR. The gate current varies from few milliamperes to 200 milliamperes or more. If the gate current applied is more, then more electrons are injected into the junction J2. Okay, so it results to come into conduction state at much lower applied voltage. So in gate triggering method, or in this method, a positive voltage applied between gate and cathode terminals. So here we can use three types of signals to turn on the SCRs. Okay, so they are AC signal, DC signal, and pulse signal. Okay, that means we can apply here AC voltage across gate and cathode terminals, or DC voltage, or pulse. Right? So if we apply DC voltage across gate and cathode terminals, then the type of triggering is called as DC triggering. If we apply, okay, the AC voltage across gate and cathode terminals to turn on the device, so the type of triggering is called as AC triggering. If we apply a pulse across gate and cathode terminals to turn on the SCR, the type of triggering is called as pulse triggering. So number one, DC gate triggering. In this triggering, a sufficient DC voltage is applied across gate and cathode terminals in such a way that gate is made positive with respect to cathode. So then whenever gate signal is applied across gate and cathode terminals, it injects the electrons into the junction J2, then device will be conducted, or it gets triggered, right? So the gate current drives the SCR into the conduction mode. But you know, in this type of DC gate triggering, a continuous gate signal is required to apply across gate and cathode terminals to keep the device in on state. So this causes the more power dissipation internally in the device. So that is why the power loss are more in this type of DC gate triggering. Okay, so DC gate triggering has a drawback that because of continuous gate signal applied across gate and cathode terminals, the power loss are more. Next, AC gate triggering or AC triggering. This is the most commonly used method for AC applications, where the SCR is employed for such applications as a switching device. With the proper isolation between the power and control circuit, the SCR is triggered by the phase shift AC voltage derived from the main supply. Now let us see to understand how the AC gate triggering circuit is appearing. Right, here there are two circuits mainly in this type of gate triggering, that is main circuit and control circuit. Main circuit is connected to the anode and cathode terminals. Control circuit is connected to the gate and cathode terminals. This is the circuit for AC gate triggering. Here we see two circuits. One is power circuit and another one is control circuit. Power circuit is connected across anode and cathode terminal. That means main supply. Okay, main supply is connected across anode and cathode terminals. Okay, so with proper isolation between this power circuit and gate circuit, okay, so the SCR is turned on. The SCR is turned on by the phase shift AC voltage derived from the main supply. But here the firing angle is controlled by the changing the phase angle of the gate signal. Okay, however, in this method there is one limitation, that is during positive half cycle of the input cycle, right, there is a forward voltage applied across gate and cathode terminals. But during negative half cycle of the input phase voltage, right, there is negative voltage or reverse voltage applied across the gate and cathode terminals. So that is why this is the limitation of this type of AC gate triggering. Not only this, here in order to trigger the device in this type of AC gate triggering, we need to use step down pulse transformer. So these are the two limitations in this type of AC gate triggering. Next, number 3, pulse gate triggering or pulse triggering. So actually the most popular method of the triggering the SCR is the pulse triggering. Compared to DC triggering and AC triggering, this is the most popular method to turn on the SCR or to trigger the SCR.
ఈ వీడియో కానీ మీకు నచ్చినట్లయితే లైక్, కామెంట్, షేర్ చేయండి. మరిన్ని అప్డేట్స్ కోసం సబ్స్క్రైబ్ చేయండి.